This is review for our test on 5.1 to 5.3. This is part 2. We're going to continue on with graphing quadratic equations, but now we're going to focus on what if we give you an equation in factored form. This is one that I would recommend you write the problem down for. So our equation that we're going to graph is y equals negative, and then parentheses x minus 4, parentheses x plus 2. So step 1 is we're going to convert this factored form equation into standard form. And how you do that is FOILing it out. So I'm just going to rewrite the original problem again. And I'm going to FOIL the two parentheses. I'm going to ignore the negative out in front. So I have x squared plus 2x minus 4x and then negative 8. And then I'll combine like terms in the middle. So 2x minus 4x is negative 2x. And then remember, you have a negative in front of this parentheses, so we have to distribute it through to all three terms. That's going to change the sign. So now we have negative x squared, positive 2x, positive 8. Now let's go ahead and identify the a, b, and c from this equation. So just like the last example, the a is the leading coefficient in front of the x squared. The b is the leading coefficient for the x term, and then the c is the constant. The degree is the same. It's an x squared, so the degree is 2, and the shape is a u. Now we have to identify, does this graph open up or down? This graph opens down because the leading coefficient, the a, is negative 1. So that means my graph is going to look something like this, where I have the maximum point, the vertex, right there. Give you a little time to write that up, that second step, part B. And then we'll move on to the axis of symmetry and vertex. Alright, let's move down now to the axis of symmetry. To find the axis of symmetry, we're going to use the same formula, x equals negative b over 2a. We'll substitute b and a into this equation. So our b is 2. And our a is negative 1. So let's reduce that. Negative 2 over negative 2 is positive 1. So the axis of symmetry is at x equals 1. Now we're going to go ahead and find the vertex. Remember the vertex, the x value of the vertex is the same x value of the axis of symmetry. So that's 1. Now we're going to go ahead and substitute 1 into either the original equation in factored form or the one that's expanded out. So we can use one of these two original problems. We can either use this one here in the blue or this one here in the red. use the blue on the original. That's in factored form. So now we're going to substitute 1 into this blue equation to solve for y. And now we use our orders of operations where we simplify the parentheses first. 1 minus 4 is negative 3. 1 plus 2 is 3. And then we multiply. Negative 3 times positive 3 is negative 9. And then a negative times a negative is a positive. So then we come over and identify our vertex is 1, 9. All right, to find the x-intercepts where it touches on the x-axis, we go up to the factored form equation and we set those factors equal to 0. So one of the factors was x minus 4, and the other factor of the parenthesis was x plus 2. We are using what we call the zero product property, and we solve those equations for x. So we're going to add 4 to both sides, and then we're going to minus 2 to both sides. So our two x-intercepts as ordered pairs are going to be 4, 0, and negative 2, 0. I'll give you some time to go ahead and finish up that part. And then we'll move on to the y-intercept. All right, the next step is to find the y-intercept. The y-intercept is the c in standard form. So if we go up, the c we identified as 8. So then our ordered pair is 0, 8. Now we're set to graph it. So let's just work backwards and we'll graph each of the pieces. So go ahead and draw up an XY plane. All right, so we'll start with the y-intercept. The y-intercept is where it touches on the y-axis. So it's going to be up 8 units. So over 0, up 8. Then the x-intercepts in the blue there are 4, 0, and negative 2, 0. So on the x-axis, 4, 0, and negative 2, 0 is where it touches on the x-axis. Going up to the next step, where we found the vertex. The vertex point was 1, 9. So let's make that one in red. So we're going to go right 1 and then up 9. So this is the maximum point on the graph. We call this the vertex or the critical point. And then we remember that our graph needs to open down. And it looks like it does from the points. So now we can draw our parabola. So our vertex, going through that y-intercept, going through that x-intercept, and then through that x-intercept. Here is the graph of this parabola. We will stop there. We're at about 9 minutes.